Hi class, this is Mr. Morris. I'm calling this the Pre-AP Chemistry Solutions Crash Course because it is basically the solutions topics that I feel like we still need to cover because you were unable to go over these in the spring. So I want to get started. I'm probably going to break this into a few videos. First of all, what are solutions? Well, let's start out by talking about matter. Remember, anything that takes up space, or it has volume, and it also has a mass, it's matter, but that can be broken up into smaller, or into different substances. So you know we've got matter. Matter can be broken up into either pure substances or mixtures. All right. Now, if it's a pure substance, that can either be an element or a compound. Elements cannot be broken down to more simpler substances by chemical change. Compounds can. All right. If it's not a pure substance, if it's a mixture, that means we've got more than one type of element or compound, and it can be broken down by physical change. You've got two types, heterogeneous mixtures. Those are the ones where you can see the difference throughout it. It's heterogeneous. It has a different appearance throughout it in one way or another. And then you've got homogeneous mixtures, which is what we're talking about in this unit. Homogeneous mixture is another word for solution. So again, a solution is a homogeneous mixture, and what that means is it's a mixture whose macroscopic properties are uniform. Macroscopic properties are the ones that you can observe without like an electron microscope or something. Okay, they're observable properties. They are the same throughout the mixture. All right, a solution is made up of a solute and a solvent. Solute plus solvent equals solution. So the solute, let's talk about what that is. That's the substance which is dissolved in a solution. It's usually the smaller amount. So in an example of salt water, salt is the solute. The solvent is the substance which does the dissolving. It's usually the larger amount. So in the case of salt water, our solvent would be water. In other words, the way that you can think about this is the solute dissolves in the solvent, and let me just add something right here. The solute dissolves in the solvent to make a solution, okay, to form a solution. Okay, solutions can exist in all three common states of matter. It could be a solid, liquid, or gas solution, or a mixture of any of those. Let's talk about a few examples. Solid solutions are usually called alloys. Those are mixtures of metals. A lot of times the way you form it is by melting a metal down, mixing it together in a solution, and then it will harden. So brass, bronze, sterling silver, and 10-karat gold are examples of solid solutions or alloys. Any gold that is not 24 karat, if it's less than 24 karat gold, that means that it is not a pure gold. It's not pure gold, and if it's not pure gold, that means it's a mixture, so it would be an alloy. Liquid solutions are probably the most common, so you could think of salt water, Kool-Aid, tea, soda, all kinds of things. And then gas mixtures, gas solutions. Well, if we have pure air, this always throws people off because pure air sounds like a pure substance. But the thing is, air, think about what it's made of. It's got nitrogen, then it's got oxygen and water and carbon dioxide and all kinds of different gases that are in it. Argon that you're inhaling. It's not just oxygen. It's not just nitrogen. It's a lot of different gases mixed together. Now, if it's pure air, that means it doesn't look cloudy or foggy or anything like that, but it's still a mixture. It's a solution. Okay, helium mixtures for balloons are also gas solutions. Let's look at these terms down here at the bottom of our first page. Insoluble versus soluble. I want you to know that insoluble means it's unable to dissolve, but it's unable to dissolve in a given solvent, whatever that solvent is. So an example would be sand. It's insoluble in water. Sand does not dissolve in water. If you were to stir it up, it just sinks to the bottom eventually. Soluble means it's able to dissolve in a given solvent. An example of that would be sugar. Sugar being soluble in water, or salt is soluble in water. Now, when we talk about immiscible or miscible, It's very similar, but the difference is it's specifically talking about liquids mixing in liquids. So an immiscible substance is a liquid that does not mix in another liquid. Examples of that would be oil and water. Oil and water are immiscible because you cannot dissolve them in one another. Miscible refers to two or more liquids that can mix or that are soluble in each other. An example of that would be rubbing alcohol or vinegar dissolving in water. Both of those will dissolve in water, so we could say they're miscible in water. That's just a basic look at the first page of the notes. Let's go a little bit farther. Like dissolves like. This explains just the rule of thumb in deciding how things will dissolve. Polar solutes dissolve in polar solvents. So we're talking about polarity. That's something we didn't talk about a whole lot last year, but you got to look at the shape of the molecule and if the molecule is made of different types of atoms. If a solute is polar, it will only dissolve in a polar solvent. An ionic compound will also dissolve in a polar solvent, and so will acids and bases. Nonpolar solutes dissolve in nonpolar solvents. So just a recap, polar solvents are water. Water is an example of it. They will dissolve polar covalent compounds like sugar, ionic compounds like salt, acids like vinegar or hydrochloric acid, bases like NH3, that's ammonia, or potassium hydroxide, and so many others. Okay, these are all things that will dissolve in a polar solvent because there's a charge. Polar solvents have a partial charge, so they're going to attract to anything that forms a charge. So that could be a polar compound, an ionic compound, an acid, or a base. Nonpolar solvents, like oils, will dissolve nonpolar covalent compounds, like another oil of some sort, or sand, or something else. All right, I'm going to go ahead and pause the video here and resume with rate of dissolving, rate of dissolution in the next video.